Okay, so let's look at trig or trigonometric graphs. So we know we have the main functions. We have sine, so I'm going to write sine of x. We have cosine of x, and then we have the tangent of x. So we're going to look at just these three graphs, and we're going to see how we use these graphs to solve equations. So let's draw our y and x axis first. So let's do it here. Should be good, and that should be good. Okay, so we need some labels first. So sine goes between 4, 6, 8, 1. So it goes between positive 1 and 4, 6, 8, 10 and negative 1. So sine of x always goes between positive and negative 1. So you won't ever need more than this for the y-axis. For the x-axis now, it goes as much as you want. So in the both positive and negative side, it goes to infinity. So let's say you have 90 degrees over here, and then you have, let's keep the same space. So after 3 more, you have 180 degrees. We'll do 90 degrees intervals because, you know, that makes sense with these graphs. You will see why. Let's say we have 270, and then we have 360 right here. Wait, I did 270 in the wrong place. So we have 270 right here, and then we have 360 right here. Then on the other side, we also have, so let's do negative 90 now, and then that's negative 180, and then negative 270, 1, 2, 3, and then negative 360. So I'm going to extend the axis. I think we can draw both sine and cosine on the same graph, and you can see like the relationship between them. So I'm just going to make it full right here and right here. Okay, let's start drawing them. So we're going to start with sine. So the way you draw is you take your calculator and you put in numbers. So this is 0 right here. So you put in sine of 0 and you're going to get 0 back here. Then you put in sine of 90 and you should get 1 as your answer. That means we plot the point 90 on the x-axis and 1 on the y-axis. Then you put 180 in your calculator and you get sine of 180, which is equal to 0. You can put this in your calculator and you will see. Then you put sine of 270 in your calculator and you will get negative 1. So then you put a point right here. And you put the sine of 360 in your calculator and you will get 0. So you put a point at 0. Put the sine of negative 90 in your calculator, you get negative 1. You put the sine of negative 180 in your calculator and you will get a 0. Put the sine of negative 270 in your calculator and you will end up getting a positive 1. And you put the sine of negative 360 in your calculator and you will also end up getting 0. So now you just connect these points, and this is not a line, it's a curve. So make sure you draw a curve, not a line. So I'm trying my best to connect these points while making it look like a curve, but of course it's not exact. I'll probably put like what they actually look like up on the screen right now, so you can see how close we are. So it goes to 180, it goes to 0, and then goes back down to 270. And then goes back up to 360. So this should be a smooth curve, and this is the curve y is equal to sine of x. Now, the important things about this curve. So some things about this curve. So it repeats every 360 degrees. So you see over here minus 360, you go up, you come down, and then you go to the negative side and you come back to 0. And then you repeat the same thing again. You come up, come down, go down to negative 1, and then come back up to 0. So its period is equal to 360 degrees. And its amplitude, these are just like the actual words for what's being said, is equal to, well, the amplitude is the distance from the equilibrium point, which is the middle right here, because this is the middle, to the peak of the curve, which is this point right here, because it's the highest at positive 1 and the lowest at negative 1, right? The highest at positive 1 and the middle point is 0. So what's 1 minus 0? Well, that's equal to 1, right? So its amplitude is equal to 1. These are the two important things about sine. And the most important thing actually is that it repeats every 360 degrees, and we'll use that to solve this equation right here. We have an equation that we need to solve. Anyway, let's get back to it. So now we draw cosine. So you can try put the numbers in again, but I'll just draw the important parts. I know what it looks like, so I'll just draw it. So it starts at 1, goes down to 90, goes all the way to negative 1 at 180, and then comes back up to 0 at 270, then goes up to positive 1 at 360. And then on this side, same thing, goes down to 0 at negative 90, goes all the way down to negative 1 at negative 180, comes back up to 0 at negative 270, and then goes up all the way to positive 1 at 360. I'll also put the cosine curve up so you can see. And you can see that sine and cosine are very similar. So this is sine, and this is y is equal to cosine of x. And you can see its period is again 360 degrees, because if you start here, right? You start here, you come down, and you end up at positive 1 right here. That was at 360 degrees. And then same thing here, you go down and come back up to positive 1 at negative 360 degrees. So this also has the period of 360 degrees, and also it has amplitude 1, because the equilibrium point is 0 and it goes up to 1. So both sine and cosine, so I'm going to draw it like this, sine of x, and I'm going to do cos of x right here. This means that the sine of x and the cos of x are always between positive and negative 1. You can't get a higher number than that. That's just the formal way of writing it. So now tangent of x, this is a more interesting one. So how do we draw tan of x? So of course we have our x's again. I'm just going to draw a rough sketch, and I'm not going to label everything. So tan of 0 is 0. Tan of 90 is, let's say, if this is 1 right here, then let's say this point right here, let's say this y-axis just continues forever, right? So let's say that that's like a very big number. Let's say it's like 99999. It's like a very big number. The whole point is to make it a very big number. And then here we have negative 1. And then again, if you go down, let's say over here we have negative, 99999. It's a very big number. Here we have, let's do it here. Here we have negative 90. And here we have positive 90. So I need to notice this about tan. So tan repeats every 180 degrees, because this is what it looks like. So it starts off extremely, extremely low, like almost negative infinity. At negative 1, it's at negative 45 degrees. Comes up, goes up to 0 at 0. Comes back up to 1 at positive 45 degrees. And then keeps on going all the way to infinity at 90 degrees. And then you can just repeat it again. So here, you draw the same thing. Comes up, comes up, comes up. And then goes up all the way. And same on this side and that side. And you can see, this one repeats between negative 90 and positive 90 degrees. So what's 90 minus negative 90? Well, that's obviously positive 180 degrees, right? So the period of this curve is equal to 180 degrees. Now what about the amplitude of this curve? Well, it doesn't have an amplitude. Or if it does, it would be infinity. Because there is no maximum point of this curve, right? You can see the equilibrium point would be 0. But then it goes up all the way to infinity. So I guess you could say infinity, but also you could say it doesn't really have an amplitude, because there is no end to this curve. So those are just what they look like. I'll put pictures of all these three side by side as well, and maybe you can compare it. But now let's do the question, because we need this to solve some equations. So we have, solve the equation 5 sine of x is equal to negative 3 for x between 0 and 360 degrees. Okay, this is important because we know our answers have to be between 0 and 360. And we're probably going to have two answers, but let's see. So we have 5 sine of x is equal to negative 3. So we don't know what 5 sine of x looks like. But we know what sine of x looks like. And we know what negative 3 over 5 looks like, right? If I told you to draw y is equal to sine of x, well, you just give me what we drew right here. Sine of x, we already drew that. If I told you to draw y is equal to negative 3 over 5, well, you just draw the line y is equal to negative 3 over 5. Let's draw that better. So we have the y-axis and we have the x-axis. So negative 3 over 5 would be somewhere over here, right? Let's say it's over there. That means negative 1 has to be somewhere here. This is all rough. Let's say positive 1 has to be somewhere here. Now, what does sine of x look like? It goes up, comes back down, goes down all the way to negative 1, comes back up to 0. Right? This is 180 and this is 360. So we know this already. And then on this side, it goes down, comes up, and then goes up, and then comes back down. I'm just drawing a rough sketch, and we know this is equal to negative 180, and this is equal to negative 360. But we don't care about the negative side for now, because it says you have to solve for x between 0 and 360. So we only have to solve in this interval right here. So now how do we do this? Well, the first thing we can do is we can take a calculator out, and we write this equation as sine of x is equal to negative 3 over 5. If you divide both sides by positive 5, you get sine of x is equal to negative 3 over 5. And now you put it in your calculator. So what you do is you press shift sine, so you get sine inverse. It looks like that. And then you put negative 3 over 5 in your calculator. And you end up getting, let me put that in there. You end up getting negative 36.87 degrees. Okay, that makes sense, right? Because negative 3 over 5 is this point right here. This is negative 0.6. And so that means we're getting this number right here. We're getting negative 36.867. Now, the real question is, do we need this number? No, because our interval is only between 0 and 360, and this is a negative number. So this is not very helpful. But we can see there still will be two answers, right? Because there is an intersection right here, and there is an intersection right here. So we still do have two answers. We need this number right here, and we need this number right here. But we don't know how to get that yet. But we can think about it. Sine is very symmetric, as we noticed, and we also see that it repeats every 360 degrees. So if I add 360 to this number right here, I'll actually end up getting this number right here. So if you add 360, you end up going from here all the way to there. So if I do negative 36.87 plus 360, I end up getting 323.13. So that's one of our answers, 323.13 degrees. Okay, how do we get the other answer? Well, sine is very symmetric. Between 0 and negative 180, you can see this answer is also 180 minus that answer right there. If you do 180 minus negative 36.87, you'll end up getting that number right there. Right, so let's do that first. So let's do 180, or let's do negative 180 minus negative 36.87. We end up getting negative 143.13. And now again, we know sine is repeating every 360 degrees, so if you add 360 to that, we should end up getting that number right there. So let's add 360 to that. And we end up getting 216.87 degrees. And let's check in our calculator. So I'm going to put sine of 323.13 in my calculator, and I end up getting negative 0.6, so that's correct. And then I put sine of 216.87 in my calculator, and I end up getting negative 0.6 as well, and that's correct. And that makes sense, right? We had to use the properties of this graph. It's very symmetric and repeats every 360 degrees. And that ended up getting us the two answers we need. So we got 216.87 degrees, and we got 323.13 degrees. So what did we do and how did we do it? So we had 5 sine of x is equal to negative 3. We don't know what 5 sine of x looks like because we've not learned that, but we know what sine of x looks like. So we draw sine of x, and then we realize we have y is equal to sine of x on one side, and then we have negative 3 over 5 on the other side. So if you end up drawing y is equal to negative 3 over 5, which is just a horizontal line, and you draw y is equal to the sine of x, which is a curve, you end up seeing that it intersects at 4 different points from what we have right here. We have this point, this point, this point, and that point. And when you put it just in your calculator, you put the sine inverse of negative 3 over 5 in your calculator, you end up getting the negative value for it, which makes sense because the calculator is going to go for the negative value because you put in a negative number. But we don't need the negative value because our question says only work in the positive range for positive domain for x. So what we do is we take the first negative value and we add 360 to it, and we end up getting the second positive value that we need. That works. And then we also see that it's symmetric between 0 and negative 180, like right here between. This is the line of symmetry for it. This is negative 90, and it's very symmetric around that as well. So then what we use that fact to find the other point in the negative side, which ended up being negative 143.13, and then we added 360 to that because it repeats every 360 degrees, and we ended up getting 216.87 degrees. So yeah, that's how we use this curve to actually solve equations, because just having this right here would end up with us having this right here. And this is not very useful if you want to solve in only the positive side for x. So yeah, hope that makes sense. I'll put the sine, cosine, and tan curves up again if you want on the screen. And yeah, take a look at them, try it, draw them yourself, and yeah, I hope you enjoyed the video. If you did, like, share, subscribe, and comment, and let me know what else you want to see in future videos.